Okay, to finish up activity 17-2, it wants to know what can we conclude about the pre-image and the image and each one of the things, and every single time because of the dilations we ended up with the same shape, just different sizes. So that's what I would write. Similarity transformations is a transformation which results in a pre-image and an image having the same shape. Notice it doesn't say anything about the same size. So they want us to fill this in, complete the Venn diagram using each of the transformations on the right. So they want to know which one of these or which three, obviously, of these transformations cause congruence, and those go in here, and then which ones cause similarity. Well, heck, all four of these are in the similarity because if it's a congruence, it has a similarity ratio of 1 to 1. So that's why they're all considered, even if they're congruent, they're still considered similar because they just have a scale factor of 1. So you got to know which one is different from the other three. So go ahead and try to fill that in. Stop the video, fill it in. I'm about to click over to the teacher and show you the answer. Okay, so translations, rotations, and reflections. These are all rigid motions. They cause a change, but it does not change the size. So those are why they're called congruency transformations. Dilations are the only ones that change the size. And like I said, these are also considered similarity because it has a scale factor of 1. So similarity transformations happen every single time you do one. So that's why we're kind of studying those in detail right now. So this one says two figures are similar if and only if one figure can be transformed from the other figure using one or more similarity transformations. Well, heck, they're all similarity transformations. So can we get this one right here to this one? Well, it's obviously a different size. So that means it's obvious that a dilation has taken place. But if you go to the side links that are similar, I mean, we see that this one right here is the longest side of the pre-image. It has a measurement of 4. This is the short side. It has a measurement of 2. You take those measurements of this image over here, and if you want to find the scale factor, you always put the image measurement on top and the pre-image measurement on bottom. The original one should always go on bottom. So I chose to put the short side over the short side, and that's so I wouldn't have to reduce. If you put 6 over 4, it reduces down to 3 over 2. So the scale factor right here is 3 over 2, or think of it as 1.5. Okay. They didn't give me any information about the center of dilation, but they've kept it pretty consistent, and they've got E right here marked. So I'm assuming that it doesn't, I don't think it says. So I'm assuming that E is the center of rotation. So I went here and let me undo this. So I did, okay, I'm going to rotate this, I'm going to dilate this about this point, and the scale factor is 1.5. I press OK, and it gives me this. Now, this right here is not this. But we've got a couple of options that we can do. We could translate it. We could reflect it. We could do lots of things. I don't know if it'll let me move this one or not. No, it won't because it's the result, but I could trace it. So let's see if I go over this. And, oops. No, I don't want to do that. Okay. So now I take this one. Okay, maybe it didn't. Let me try again. And I'm going to get off of that so I can should be able to drag it. Okay, I don't know why that's not letting me drag it. But anyway, you've got to decide which one of the, which transformation you want to do. We could certainly just translate this point right here. Let's see, that's a half, so that's 1, 2, 3, 4, 5, and that's another half, so it's a total of 6. Well, let's do it like this: 1, 2, 3, 4, 5, 6, 7. We could translate it 7 units. So translate that 7 units, and if you translate it 7 units to the right, then all of these points would end up over there. I can tell you what Springboard did. Springboard said, hey, we're going to get into my pen. They reflected it about this line right here. And then if you reflected about this line, then this one flips over here, this point flips over here, this point flips over here, and this point flips over here. So that's what Springboard said. It's not the only answer, like I said. We could also translate it. But here it says rectangle ABCD is dilated by a scale factor of 1.5. Well, we figured that out about the origin. And then it reflected about the line x equals 5. That maps A to I and B to J, B to J, D to L, C to K. And this would be do the dilation first and then do the reflection. And it does matter what order. Dilations should be done first. That's generally the order. I mean, you do whatever it says, but if you reflect it and then dilate it, you're going to get a different answer than if you dilate it then reflect it. Okay, so let's go back and see what else. Oh, it's the end of the unit. So you're going to do check your understanding and the practice. And I will do one last video that contains the answers to these. And then I will do the last lesson for this one. I never can find where to stop.